Okay.
I thought you were talking about the other reaction.
No, we've switched over to the next section here. Okay, this section I think is very interesting, and I think it's important. I'm not going to really lecture on it. I'm not going to test you on it. But this section shows how these concepts that we've studied about energy apply to practical matters of energy usage and pollution and different things. One of the things I would like to point out here is that fuels differ in the amount of heat to carbon dioxide that they produce. Okay, so we want to minimize the amount of carbon dioxide that's emitted when we, burn fossil fuels, gasoline, anything like that. And so some compounds will give you more energy per amount of carbon dioxide than others. And so those are considered to be better fuels. Question?
If you were paying 12 cents per kilowatt hour, that would be like $12,000.
If you're paying 12 cents per kilowatt hour, so 0.12.
That's a lot, no?
But this is including like using gas.
That'd be 12,000. That'd be $12,000. Yeah, but it's not all from electricity, and it's not. Yeah, I mean, some of these numbers are kind of mind-boggling. Yeah, you can convert kilojoules to kilowatt hours. Yeah, and it's really, really important to look at the units when you're comparing things, right? Because you can't compare apples and oranges. You can't compare kilowatt hours to kilojoules. They're not the same unit, right? So there's some pretty interesting stuff in this chapter. I mean, this section of the chapter, but.
How much energy does the human body produce in a year?
That's a good question. How much energy does the human body produce in a year? I mean, you could look at how much heat energy you generate, how much energy is generated by exothermic processes in your body. You could look at how much energy you need to consume, right? So you could look at your calories burned. That's a very good question. It is going to differ from individual to individual. One way you could estimate that is if you figure out, I think they say 1,200 calories per day for the average person, right? And so then if you multiply that by 365 days, and those are kilocalories in science, that would give you an idea of how much energy is involved. Because your body, you get your energy from the food that you eat, right? And then your body does all these chemical processes. And it uses the energy for various things, like keeping you warm and breathing and moving and things like this. It's an interesting question.